Hey, welcome everybody. Good afternoon. This is Jim Warren with TXAPA. I'd like to welcome you to our troubleshooting series. And to introduce today's lineup, I'm going to bring to you Mr. Chuck Fuller.
Thank you, Jim Warren. So today's lineup, we have Lance Townsend, who is with Heritage Asphalt. Lance is is over all the asphalt plants for Heritage Asphalt. We have Scott Thompson, who is the plant manager for all the asphalt plants for Lone Star Paving here in Central Texas.
Wave, Scotty.
There you go, Scotty. And then we have TJ Young, Duval Asphalt. TJ is also a consultant, has worked with us in the past. TJ, thanks a lot for being here again as a plant manager. And then we have Ray McPherson with Jagoe-Public, who is very familiar with asphalt plants, but he's also QC. So we brought in a lab rat to be able to offer his part of the troubleshooting guide. So what we're going to do is we're going to come at this with some questions, some issues that happen at the asphalt plant, and we have plant managers, and what we're going to ask them to do is be able to discuss or how they would come apart or how they would see these different issues and how they would explain to their plant operators what to look for. So that's real important, what to look for. So we're going to go through a process, and this process is going to be based from a plant standpoint, okay? So it might not be the mechanical aspect of it, or it might be. So I think we have a pretty good program set up. We got 4 of the leading experts in this field. And again, thank you very much, TJ, for being with us. You come highly recommended by Jim. And of course, we've had several conversations, and I really appreciate you guys being here. To start us all off, I'm also going to do the safety share. Jim will be the commentator and dealing with the questions, but I'm going to do the safety share, and then I'm going to follow up with anything that I see that you guys might have missed. So the safety share, by the way, is on our TXAPA website. Okay, when you go to our TXAPA website, texasasphalt.org, underneath resources, you'll see the safety shares. We have hundreds of safety shares out there. Utilize these safety shares for your toolbox safety meetings. They're available again online. You don't have to log in or anything. Anybody can access them, so they're readily available. And our texasasphalt.org website is a great resource tool. Please utilize it, and we'll talk a little bit more about that at the end of the day. But today's safety share is PPE. It's hard hats. So we're talking about personal protective equipment, and we're going to specifically talk about hard hats. Hard hats provide a shield for your scalp, face, and neck, shoulders against falling objects and dangerous liquids. When impacted, the suspension system inside your hard hat acts like a shock absorber. Some hats even serve as an insulator against electrical shocks. You know, for this reason, it's important to evaluate your hard hat and all your PPE to make sure that it's in wearable conditions before entering a lab or job site. And here's a few tips to ensure that. Do not leave your hard hat in a place where there's high temperatures or that will weaken the shell of the hard hat. Clean your hard hat with mild soap and water. Avoid contacts with chemicals, solvents, or gasoline, because that can damage, again, the exterior side of your hard hat. Never wear a cap or a baseball hat underneath your hard hat, or put anything in that space between that suspension of the shell and the shell itself. That's real important because they act as one unit. And do not puncture, modify, engrave the shell or the suspension of your hard hat. And also, it's an important element to know when safety and knowing when your hard hat needs to be replaced. If there's visible dents, cracks, a loss of gloss, or any other sign of a detriment to that hard hat, you need to go ahead and replace it. If a hard hat been struck with a forceful object, even though there's no obvious danger, we need to replace that hard hat. If the suspension inside your hard hat is cracked, frayed, or torn in any way, we need to replace that hard hat or the suspension. And then again, even if you maintain your hard hat well, they still need to be checked, and they still need to be replaced every 2 to 5 years. Okay, so that depends on the usage, but typically that's when you need to replace your hard hats. So again, TXAPA.org, resources, safety, shares are right there. And again, utilize our website. Jenna and Emily have done a great job in putting that thing together. They update it every day, and it's a great resource. So Jim, back to you, buddy.
Thank you, Chuck. Okay, let's reminder just to everybody, we can go ahead, we'll take your questions at any time. Go ahead and just type them in the question box, or if you want to know some more, want some more detail about what we're talking about, please just go ahead and weigh in. Let's go ahead and get started. We started last time, a couple weeks ago, we started with a mixed design troubleshooting, and today we're doing plant issues relative to troubleshooting. Next Tuesday at 3 o'clock, we'll be doing paving. And so we're trying to cover the gambit, just like we did in August with our Optimize series. And that's where you saw TJ the first time with our Optimize series. And we're just kind of trying to go a little bit deeper, trying to develop some of these troubleshooting skills. We've got some time. Things are starting to slow down. For a lot of you guys, it's been a record year. And so now it's time to kind of take a little bit of breath and maybe probably hopefully do a lot of maintenance to get ready for next year. So we still got a good program lined up for next year. So for the audience, now is your chance. Okay, so what we're going to be spending some time today on is what are you going to do? Okay, and a lot of times there's an immediate response to a situation, and that immediate response will be, okay, I got to fix it. I got to keep going. There's also maybe what we would call a measured response. What should you be doing? And so obviously in the process here, get it out of the way, is we want to look at what the causes of these issues are. What steps do you take to resolve them? And most importantly, what is the impact on performance when one of these properties is out or sliding out or moving out or trending or high or low or shifting? What can be because if the mix doesn't work, well, we got a problem. So we got to make sure the mix is working. So, and then the other thing is associated with this is what do you do to the plant? Do you fix it on the fly? Or do you do a temporary shutdown? Temporary shutdown, also known as a hot stop, timeout. What else did you call it? You had another word for it, Chuck. Can't remember what. Hot stop, yeah, timeout or whatever, just a break, but not necessarily going to shut the whole system down. And in some cases, if things are bad enough, you may just need to say, man, we got to shut the plant down and figure this out. Or if something's just that far out that we've got to resolve the situation. So those are the things that we're asking you as the audience today to go ahead and weigh in on. What do you think the causes are? What would you do? And what would you do to the asphalt plant in the meantime? Again, we're coming at this, as Chuck said earlier, from a plant-related aspect. So the problems we're seeing are the only way to fix it is you can't blame the lab guy because we're saying we've resolved that issue. You can't blame the roadway. We're saying it's something that the asphalt plant has to resolve in order to do this. Now, in a true troubleshooting fashion, you would look at all those other areas. But today, since we've only got an hour, we're going to spend time just on this. So let's go ahead and get started. And I've got my first issue is my mixed temperature is running low. My mixed temperature is running low. And let's go to our group here. Okay, Lance, I'm going to start with you. Okay, what's the first thing you're going to do when you got a mixed temperature running low? QC guy says, hey, we're 25 degrees low in the truck. What's your response?
I'm going to say, are you sure? Have you calibrated your temperature gun?
It didn't take long, did it?
No, it didn't.
We're gonna look and see, is this has this been a gradual problem? We're going to check our temperature gauges, and we're going to check our guns on the plant that we usually have set up on the drag and all that kind of stuff. And we're going to definitely do an internal check, make sure that we're doing things the right way.
Good. TJ, what are you going to do?
Well, first thing I'm going to do is look at, like you said, you want to check your thermometers. We always keep 2 of them at the rack. So we'll put a temperature in the truck here. So we'll do that. And if they match, then we're scrambling. The next thing I want to look at is what I call shoot the truck route. When you run into, we'll get into this in more details, but if you move to a higher raft, you have a bigger rock mix, you'll be seeing temperature drop. So if you're dealing with a drop from the chute to the truck, it's a bigger issue, and you need to crank up the heat. You know, give it another 5% on the burner and see what happens.
Okay. All right. Scott, how about you?
I mean, you know, first thing, we're going to go look and we're going to watch our chart at the plant. You know, that's the first place you're going to see that drop. You know, if you're seeing it on your chart, you can also see it down the road. You know, if we get a temperature, you know, I'm going to send somebody out. They're going to check the pressure, make sure it's in place. You know, it has got a chunk in front of it or push the flow of asphalt.
Oops, that didn't work.
So we actually have 2 temperature feedbacks on the plant.
Okay.
You know, and if you're watching your plant, none of your other stack temperatures or anything else are adjusting, you know, then it could just be a problem with the monitor.
Okay. Okay. How about you, Ray?
You know, basically the same thing. You start looking at the plant first, you know, and looking at the temperature chart, see if we see anything different there, see if we had a spike, see if we had a dip in temperature. You know, same thing Scott said, you know, you're going to, you know, if you're running wrap or recycle, you're going to look at those things. And, you know, you have to take into account your moistures of your aggregates and, you know, just, you know, so many things that need to be checked before you start jumping the gun and pointing fingers.
So what's the process that you guys go through in order to sort that out? I mean, obviously with experience, you kind of know maybe what, you know, 50, 60, 70% of the time things are going to be. But what's the process? I'm interested in the process to which you go about doing this. Anybody?
Well, you know, at first as we take oh, you're talking to somebody else.
No, go ahead, Ray. Go ahead.
Okay. Well, I mean, the process we take is we are going to check our guns just like it was stated earlier. You know, we're going to make sure that everybody's getting the same temperature and it's not just us or the plant. Plant also has, you know, temperature guns all over the place that they're checking for us constantly. But, you know, once that happens and say we, you know, do start getting cold asphalt, and, you know, we just start at the bottom, work our way up. We start asking all the questions.
Okay.
What's that?
Go ahead.
Nah, sounds cutting out pretty bad.
Yeah, I'm sorry. Go ahead.
No, that's fine. You know, then after that, it's just you have steps you take and you do it as a process. I mean, that's
If you watch.
Go ahead, Scotty. Whoops.
Oh, I think we just lost
One of
Scott.
the things that I would do is, you know, depending on how much rain we had and all that kind of stuff, you know, I would make a trip out and see as we're running and trying to fix this on the fly, I'd take a drive back and see what the loader man's doing, making sure that he's keeping his bucket above, you know, and those
Good
kinds
point.
of things also. That, you know, those guys are kind of the lifeblood of the plant. You know, whatever they're feeding definitely affects you.
Good job. TJ?
Can I jump in?
Yeah, please.
Usually the operators, the first thing they're on the phone with or on the radio with is the loader guy. Like I said, are you feeding me wet material? Okay. And the thing that I want to stress here is that you're in Florida where we get a lot of rain. We see this a lot. So when you get more moisture in the material, the biggest thing to look for is your big rock mixture. So you usually see these complaints occur on your larger rock mixes, you know, your half-inch mixes, your 3/4 mixes. And it takes a lot of energy to get those big stones completely heated through. And so you'll see a lot of drop in your temperature from your chute to your truck. So the operator thinks he's doing a great job. And if he's not yelling at the loader guy, he's looking at his temperature device. Now, we always have backup for every single temperature device. So
Good. That's a good idea.
We have infrared guns like Ray said, they're all over the plant, or Lance said. But you know, what is your temperature at the chute? That thermocouple is going to be reading the liquid and the fine aggregate. When it goes into the silo, the temperature stabilizes. So the path to heat is from hot to cold. So it gets into the heart of the rock, drops the overall mix temperature. So if you're really looking at a bona fide 20 or 25 degree temperature drop, after a wet day, it's legit. You just got to turn up the heat. And that feedback between the truck temperature and the chute temperature on the plant is critical.
Mhm.
Even if you're not in a state where you really monitor, then it should be done. And then when it goes to the field, if you've got a trip of 20 miles, 15 miles, 20 miles, you can really see that drop occur. So now you're getting a phone call from the field, or you're getting a feedback from the field saying, hey, this mix is too cold, it's out of spec range. And the plant guys are standing there going, no, we did a great job. You've got to really plug into that drop. And when you add another 10% wrap to a mix, you're going to have a different temperature drop. And you need to learn that. You need to learn that for your market. And
Good.
it only takes, another 1.5% moisture for you to get into a situation.
Right.
All right, good point. So let's go ahead and wrap this up. We got other stuff I want to talk about today.
Let me
So
ask you a quick question.
Go
Your
ahead.
plant operator, what's the very first thing does? What does your plant operator do when you say, hey, we got a cold load, or we dropped 25 degrees? What's the very first thing typically, in reality, what your plant operator does is turn that burner off of auto and put it on manual, right? Is that the right thing to do? Scotty?
Mhm. You're probably a little far behind at that point. If they've got it on the road, then you're behind.
Yep. But
That's
that's really what
something-
happens, right?
Yes.
Yeah.
First thing he does is he blames somebody else. I'm doing a good job, and thermometers, their thermometers are wrong in the field or whatever.
Yeah. Well, that's the point, is that it's not
So
always
he's
the
right.
correct thing to
I
do.
mean,
It's just
You've already got a couple, 3 silos of material.
yeah.
So now you got to really figure out what's going on.
Yeah. Well, like you were saying, if you're watching that
And
chart,
if you're running along and switch, say it's a cool day, you're running in one silo all day and you switch to a silo you haven't been using, you're going to see a little temperature drop in your material. That silo will suck.
10 degrees guaranteed, right there.
guaranteed. That's a good
I mean,
point.
until that steel gets warm.
Mhm.
good point. Good point. All right, that's a good one. Good job, everybody. We're going to move on, and now again, anybody you want to weigh in, if you've got a solution, go ahead and type it in the question box and send it in. We'll read it off to everybody. If you've got an alternative solution or something that you guys do, please let us know. Or if you just got a question about what that's going to do. Obviously, if the mix is running, let me just go back to that slide real quick. We didn't talk about performance, but just a real quick. I mean, if our mix is too low in the field, we're going to have a bigger challenge getting density. And there's a lot of work that's been done relating roadway density to actually field performance. And so that's something we just don't want to give a pass. And with the 3077 and the 3076 specs having a much bigger emphasis on temperature now, both mixed temperature before it goes into paver, behind the screed, if you're running a camera. It's a lot more things going on now than there used to be. So temperature is important. We need to stay on top of it. All right. So let's move on to the next one. My binder content's running low. Okay. QC guy, or the 1A calls a tower. You guys are parked in the tower, having a cup of coffee, enjoying the day. And you get a phone call or a text and say, hey man, my AC content is 0.5% low, 0.5% low. What is your immediate response? And I'm going to go to TJ first this time. What's your response, buddy?
Dude, if we're 0.5% low, I mean, this is just us. Everybody's making their own decision. But if we're 0.5% down, it's like, stop.
Okay.
Stop shipping, figure out what's going on. That's a huge drop. I mean, we're looking at day-to-day normally a 0.2 or 0.3 drop. There, you don't really know what to do unless you check your gradation.
Okay.
So it's very important to get another burn right away.
Okay.
And, you can go on a temporary hold, or, and what you were saying earlier, Jim, I know I've only got 10 seconds, but the feedback loop needs to be shortened between the plant, the field, the density, measuring equipment.
Yep.
Those guys need to really talk to each other. And so,
Good point.
if AC is low, if it's that low, that's crisis.
Okay,
If it's a couple tenths low, we got to look at grades. And
okay,
then you've got to get another test. And it makes you nervous as heck because your voids are affected, your density is affected, and you're just nervous, you know.
all right. Scotty,
That's not a shutdown on 2 or 3 tenths, but like, let's figure out what's going on. Let's get another test.
good deal. Scotty, what'd you do? Scott? Nope.
Yeah, well, I mean, he's right. You know, that big of a drop is something wrong. You know, but I mean, there are things we look at. You know, you're looking at the mix. I mean, something that drastic. You know, somebody's going to notice it. You know, I mean,
Hopefully.
things we would check. You know, is we're looking at our belt scale and our weighbridge. Have we seen a fluctuation? Is something up and something down? Is your plant? You know, is your asphalt tracking where it should be for your production rate? You know, that's the things we look at.
Okay. How about you, Lance?
You know, I hate to pick on Ray. You know, I've already talked about a calibrated temperature gun, but you know, I'm going to go back. We've had instances where, you know, we really didn't see anything in the mix, and we had an issue. You know, an oven, or you know, the molds not coming back. You know, all that kind of stuff. So I mean, that's just a section of it, but that hadn't been touched yet.
One piece of the puzzle, right?
Right.
And yep, I agree, but I'm still trying to stay on the plant side here with this.
Right.
What do you think, Ray?
You know, same thing that everybody else saying. If you're out that much, then it's an immediate shutdown. We start looking for, you know, some of the things that we look for when our AC fluctuates is, you know, and I hate to go back to recycle because it seems like most of the time we have our large fluctuations in AC content is when we're running recycle. Now that we've kind of taken some of that recycle out, we don't experience as much. The plant stays a little bit more consistent, but it's communicating, you know, with my guy in the field. How's it rolling out? You know, my 1A, what did it look like? You know, I realize we don't visual test, but these guys have been testing long enough. They know when a mix is looking like it should, especially after 30 or 40 samples of the same mix. And, you know, so we just start, you know, basically square one and just start looking, asking questions, talking to the plant, just anything we can figure out to figure out why our AC is running low or high.
Okay, good deal.
I
How
think
about
Scott touched on it. I mean, if it drops that much, you're looking at a rock in the weighbridge, okay?
Mhm.
And sometimes your target and actual, depending on how your plant control's set, that's another thing he mentioned. That's a real key thing to look at is target and actual. And but a lot of control systems you're not going to pick that up, but a rock in the weighbridge will kill you just like that, and it can be on the rack. To reinforce what Ray's saying, here where we run 40% wrap DOT every single day, when we see a big drop, I don't know why, but it's more in the wrap side than it is in the virgin side. So I think a chunk in the wrap or stuff's bouncing around the screen, something's going on there. So we look at that. I like to have the guys just do a sequential stop, whatever you want to call it, and then see if all the scales go back to zero. Okay, so that's another thing that'll kill you. If you lose your zero for some reason, or if you haven't checked your zero, now you're really off. And you should be able to check your zeros every day, but when you shut the plant down, the zero should go down to zero. If they don't, boom, you just found your problem.
okay?
Right? If it goes down to a -30, it's like, well, okay, this is why we're short on budget. You know, this kind of stuff happens, dude. I mean, I'm a plant guy. 40 years of working on plants, you know, it's a machine and things go wrong with it. So it's constant vigilance.
Good deal.
And you know, things happen. It's mechanical device. So,
Okay, good deal. Lance, I don't think I got to you this time around. You got a comment?
No, I mean, I can echo everything they said. You know, things that we've always had issue with, we've been, you know, rocking the weighbridge. A lot of that, you know, also, hey, you know, check your feeder bins too. Make sure that they're feeding correctly. You haven't gotten something, you know, your fines aren't feeding more than they should, and, you know, vice versa, you know, all that kind of stuff.
Okay, good deal. Good deal. Any other comments on this one? You know, I'll just kind of weigh in, you know, asphalt content being low, from a performance standpoint, obviously we've got, you know, got kind of an issue there, don't we, Chuck?
Oh, yeah.
You know, I mean, if our mix has got low asphalt, we're gonna have trouble getting density. Potential for cracking, for permeability and for mixes that are not supposed to be permeable. If it's a PFC or an open graded mix, it's got low asphalt content, potential for it to ravel. So obviously, from an asphalt content perspective, we want what was designed in there. Sometimes you have to make some little plant modifications, but obviously 0.5% is a bunch. So if 0.5% is a stop for some of you guys, what's 0.3? What do you do at 0.3? Really quickly, let me go around. Lance, if you see a 0.3 out, what do you do?
I'm still going to check the weighbridge, you know, look on the wrap and the virgin side.
Okay.
I'm going to check the feeder bends, you know, make sure that, you know, go check the asphalt pump, make sure that there's no, you know, nothing out of the normal on anything that's running like that.
Good. Scotty? All right. Yeah, Scott? Anything? What do you do at 0.3?
Yeah, I mean, we're the same thing.
Okay.
We're watching our weighbridge, you know, watching, you know, our actual, what we're shooting for, and you know, 0.3, that's maybe, hey, let's grab another sample real quick.
Okay. Good. Ray, you concur?
Yeah, that's what we do. I was going to say the same thing. You know, we'll grab another sample as soon as we realize there's an issue and we need the plant to start looking. While they start doing their stuff, we'll pull another sample, run another burn real quick, just to make sure, you know, we can tell within 15 minutes if it's trending the same way. You know, go back and look at the burn tickets, stuff like that.
Okay. TJ, you got the last word on this one.
Yeah, no, I'm with these guys. I mean, 0.3 is like the real worry number, right? And I'm with Ray on 100%. And we do the same thing.
Okay.
And you want to look at gradation. We're going to talk about gradation going fine next, but
Yeah.
gradation and wrap follow. I mean, gradation and AC follow each other. So if you're really running consistent low AC, you got to look at those grades, because you may have had a problem with the feeder, a problem with the rock, or a problem with the wrap, and it went coarse on you. So when it goes coarse, your AC is going to drop.
Gotcha. Okay.
Just a real quick comment. Do you, your plant operators notify your lab when you do a switch over? Like when you're switching from a C cat to a D dog, or vice versa, do they have that conversation back and forth? Because that's where you could see a fluctuation in your AC content and your gradation if you don't catch that switch over correctly. You guys communicate that, or have your lab or your plant operators communicate that to your lab guys?
Oh yeah. If there's been a lot of switchovers, we try to run consistent run. If you get a lot of switchovers, you're setting yourself up for.
Gotcha.
I mean, it's nice to believe that you can only have one load of mix that's not exactly perfect on a switchover. I think that's not the real world.
And in the real world, it doesn't work that way, does it?
Yeah. So if there's a lot of switchovers, or there's any kind of condition, we beat our operators. We just beat them over. You know, I mean, we all get along great, but it's like, dude, if you had a problem with the plant, you call the lab. You tell them you had a problem with the baghouse, you had an upset condition, something happened. You try to figure out where it is in the silo and communicate, and that helps a lot.
Yeah.
Good deal.
Good
deal.
point.
All right, let's move on. As TJ said, mix is starting to run. Gradations are running fine. I'll let you figure out what. I won't pick a number, but let's just say the gradations are running fine. And what are you going to do? What's your first action? And again, anybody who's online, go ahead and type in what you think is what you would do. But what would you do? Let's start with Scott this time. You got to find gradation. What's the first thing that you look at?
Find gradations. I mean, we're looking at our material. You know, we're gonna see if there's something noticeably that's changed. You know, or maybe we've got a feeder choking up. We're forcing out and not getting the material we need. You know, your loader guy should be paying attention. You know, if he's getting some rock just right, you know, instead of just pushing up and go with it, you've got to communicate if they're seeing issues with it.
All right, good deal. Hey, Scott, I'm getting a lot of feedback. Would you mind muting when you're not talking to see if that might help us out? I'm just still trying to figure out where this feedback loop's coming from, and I appreciate it. Let's go to Lance.
Yeah, I'm gonna go back. You know, we've always had our lab guys try to do the gradations of all the materials, and go back and check that. Feeder bin is really important. Bins, are watching everything. I mean, I echo everything. Make sure your screen decks are clear. All those things like that.
Okay. All right, good deal. TJ.
The key thing there is look at least two different samples. The first thing I think about is a bachelor problem. So I want to know I've got two samples in a row that are consistent in gradation. If they are, okay, we got a consistent issue. 90% of the time, it's a calibration problem with the feeder, like somebody took a rock out of the bin, pulled the gate open, didn't put it back in the right spot, and that's very, very common. It's a very common problem. Or there's a gradation shift in the aggregates. So you got to look at the consistency. The key to this whole thing is consistency. I want to see 2 or 3 samples. If they're fine, then we'll make an adjustment. So you're going to make an adjustment on the fly and figure out your other problem later.
Gotcha.
But if they're consistent, but if they're confined and coarse, then okay, you've got a segregation problem. And you can have a segregation problem just loading the truck, or there can be a problem, taking a sample and getting it on the bench. I mean, we've all seen that. So you've got to have 2 of them. You got to be looking at 2 of them and figure out if it truly is a consistent gradation issue, and then the AC is going to follow it.
Yep. Okay. Ray, I'm going to unmute you. Go ahead. Or I guess you're okay. You can unmute yourself and then go ahead and give us that. Go ahead and there we go.
All right. Did that work?
Yeah.
Okay. Yeah. Same thing all these guys have been saying. We do the same thing. We run stockpile gradations a minimum of once a week on every material that comes in that yard. Sometimes 2. It just depends on how many tons we're running, our production rates, how fast we're putting that mix in, and how fast this aggregate's coming in as we're pushing it out the door.
Mm-hmm.
Kind of the same thing. We'll go back and look at our gradations that we ran and compare them to, our current gradations, and go back and look at the original design versus, what's currently here, and adjust our bin percentages that way. I mean, there's a lot of different ways that you can do it. I mean, I've found that consistency from the quarry, it's not slamming the quarries, but sometimes it is what it is. You get what you get, and you just got to make the best of it. Yeah, you can sit there and you can complain and gripe and moan, but you get what you get, and you just got to do your best. And a lot of that has to do with good lab guys, your 1As that know how to communicate, talk. They see these problems. We have the same with loader operators. They let us know, hey, this rock doesn't look right.
Good.
Hey, we've even got the truck drivers say they loaded us out of a different stockpile today. Y'all may want to check it. Problems that way.
All right,
So,
that's a good notice. Hey, Chuck, now you had mentioned earlier, we're talking about now gradation in Texas is not a pay sieve.
That's correct.
But there's a process.
Yep. So if we have 2 gradations out in Texas, then we got to shut down, right, Ray? So if you have 2 consecutive gradations out, we got to shut down. So that's one of the things.
It's 3 gradations. Well, it's three consecutive gradations on the same sieve, or any 4 gradations in a row out.
There you go. So this is like TJ just said, we'd fix this on the fly. We're going to try to fix the gradation on the fly since it doesn't have a pay factor. But
if it's consistent.
If it's consistent.
Yes.
Consistent. You're
if
correct.
For some reason we get on if for some reason we're struggling with our gradation and we're not sure if that 3rd gradation is going to be what we need, we will do a temporary stop, and kind of slow everybody down and just kind of hold everything until we can, get a sample ran. And then if we see everything's good, then we'll continue on.
I know we had this conversation with Scott earlier about the gates, somebody reaching and taking the gate and, because a big rock might have got stuck there and they didn't put it in the right spot. And Scott, what was your answer to that about drilling a hole, huh?
I mean, we pin it, we pin it, we mark it, we drill a hole where it's got to go back in the right same spot, if there's somebody guessing at where they put it, an inch difference in the gate, that's a lot more rock go through it.
And the other thing is that you've got to know your control system. Believe this or not, but some control systems control your ton per hour.
Oh, yeah.
So they look at your scale and they automatically, it's not going fast enough. They speed up your feeders. I hate those kind of control systems. So if you get a rock that's or a dead raccoon, I actually saw that once. A dead raccoon got in a feed bin, and it's plugged off a feeder, and it's changed your gradation. And if your control system speeds your feeders up so that you can always do 250 ton an hour, you've got a gradation shift. And so these things do happen. It's why the guy on the ground is so critically important. I mean, the guy on the ground, the loader guy's important. Yeah, everybody out there is important, but that guy watching the plant is key.
Great.
Good point. That's a really,
mud flap in a feeder bin is not a fun thing to deal with.
Yeah.
Especially if you're trying to dig it out. Yeah. Again, just from a performance standpoint, we've spent a lot of time this year kind of coarsening up our mixes to try to get more stone on stone contact to make sure we get good Hamburgs. If that mix gets too fine, we could be back having a Hamburg failure, which is a big problem. So, again, we want to try to run the mixes as they are designed within the allowable tolerances. All right, let's move on to the next one. We've got our dust, or our -200 is variable. It's up, it's down, it's all around. Trying to think where we ended up last time. I think we're back on Ray. I got to unmute Ray again, or I keep muting Ray because I think my sound issue is in Colorado. I think you're just too far away, buddy. You need to come back to Texas. So go ahead and unmute yourself. And what would you do if you're seeing multiple tests now? This is not a single test, but multiple tests, and your dust is all over the place. What's the first thing you're going to do?
Well, fortunately for us, we run a modified batch plant. We just installed a new dust metering system. So, we are able to pull all of our dust out, meter it back in. But, before we had this system in place, it was pulling samples, checking the bags, seeing, what was going on, why did we get so much dust and I know a lot of times the computer screen will say, hey, everything's running good here, but it doesn't necessarily mean, because like we say, we can see the results in the testing. And if we see something that's just our -200, which is something we have fought with for the past 2 or 3 years. And by putting this dust metering system in, I think we've got on top of it, and especially with our batch plant. But yeah, dust is, we've done so many tests. We've done with the dust metering system, 100% open, running batches, seeing what we get. We run cold feeds, just anything out just to see where's our dust coming from. Is our materials getting dirtier? Is it, because, like I said, being a batch plant, everything we have goes through a dryer drum, it doesn't go through a continuous flow drum. And, so that's the biggest thing for us is where the dust we're seeing, where is it coming from? Because it's obviously affecting our mix greatly when we cannot adjust for it.
Gotcha. How about you, TJ?
My turn?
Yep.
All right. If dust is variable, I start at the bag ends. Okay. If on a drum plant, now batch plant's a different discussion. There's a lot of things, more complications with the batch plant, but most of us are running drums. So let's talk drums. If it's really variable, I look in the bag ends. If it's consistent, I go look in the stockpile. Okay. So if it's consistently low, consistently high, I go to the stockpile and I go to the screenings.
Okay.
If it's a variable, I look in the bag house. I simply just hot stop the plant, crack the inspection door, spool the fan down to 10%, okay? and you got to do this very carefully. Open the door very carefully, let the dust clear, and look in that hopper. We all know what it's supposed to look like. And if you don't have a consistent flow of material in that bag house, if the screw's not loaded consistently and the hopper looks consistent, you just found your problem. And this is not an uncommon problem.
Okay.
And there can be several different things that lead up to that. But if the material is, now you've got a feed bin basically that's emptying and filling and emptying and filling. And if you add multiple starts and stops to the operation on top of that situation, that's, in my experience, the primary cause of dust variability
Okay.
in the plant.
Good. Good. Lance?
You know, to just add to that, to what everybody else, Ray and TJ have said, is upholstery boards. You know, is everything pulsing right? And it all comes back to the bag house, as TJ said, on if it's a, you know, consistent issue. But the bag house, it's where it's at.
Okay. How about you, Scott? What do you think?
Yeah, actually, a problem we've had, we had one of our plants that had been shut down for a while, and we had started running again in the bag house. And I guess some of the dirt and mud had got in, and it had clogged off 2 veins on our vein feeder. You know, so you've got a vein feeder that's turning in circles, dumping your even dust into your auger to go back. Well, 2 of the veins were completely bridged over. So you're getting product, and then, you know, nothing. And it's just giving you an inconsistent flow of dust coming out of the bag house. And
You're
that's
getting kind of just
you know, that's
slugs and then nothing.
where we looked at
Okay.
everything.
Wow. Okay.
How
Wow.
did you
They were
find?
complete.
Go ahead.
We had the auger off and just sitting there watching the dust come out, you know, going to the drum, and it would run 3 inches in the auger, and then there would be a spot, there was nothing.
Huh.
And, you know, just banging around. I mean, we had a rag one time, a red rag got in the drum somehow and got drawn over in the stack, and it actually bound up the vein feeder on the bottom of the bag house, you know, because that's what gives you that even flow of dust is your vein feeder, you know, just dropping it in steady rates.
So
Yeah,
we
what'll happen
got
is
raccoons, mud
create-
flaps, and flags. All right. Rags. Go ahead, TJ. Go ahead, Terry.
No, I was just saying, we got to move on. But yeah, that the situation that Scott's discussing is not uncommon. But what it does is then it really shorts it, and then when it starts biting again, it's biting more.
Yeah.
Yes.
So you should not see any kind of dams in the system. So if you just open the door and you look in there and you see a dam, backdrafting, tip valve that's not working, you know, there's a lot of things that can cause this. If you have a return auger that's too steep and you do a lot of hot stops, that will kill you. If you've got a steep return auger and you do lots of starts and stops, because usually it's plant scheduling issue, then you're going to be short, way long on dust, okay on dust, way long on dust, okay on dust, short on dust maybe.
Okay.
And it's consistent. A consistent run is really important. We should do everything we can try to do to create an environment where we can get a consistent run. And it starts all the way out at the paver and the planning and the trucking, and works its way back to the plant. And you know that it helps a lot. But
All right. Good deal.
variable dust, look at your dust return system.
Good deal.
Variable
Good deal.
dust.
Obviously, an impact on performance as well.
Mhm.
All right. Let's move on. Lab molded densities are running high. So we're getting 2 little air voids in the plant mix. So our lab molded densities are running high. So let's start with where we want to start with. I can't remember where we ended. Ray, I'm gonna have to unmute you and let you maybe take a shot.
Unmute. There you go.
There we go.
All right. So lab molded density is too high. First thing we're going to look at is dust.
Okay.
You know, look at our AC content. We can tell that as soon as we start, you know, burning, if it just starts jumping up super high. We can also tell
Okay.
by running our rice gravities, you know, if you know, do we see it everywhere across every test result, or is it just in one place, or, you know, we're just seeing the density, you know, that's, you know, then we'll start troubleshooting from there.
Okay. Okay. How about you, Lance?
yeah, you want to find out, if your gradation has gone finer, if what's causing AC to go up, checking if you have your wrap, if you're needing a high amount of wrap, check, make sure that you hadn't hit a rich part of the pile. That's kind of where I would start.
Okay, TJ?
Yeah, I'm same with these guys. I mean, if your voids are really, really low in lab molded, I mean, I look at dust and AC, that's where we start, and then go back from there. And usually it's AC or dust.
Okay, okay. And Scott?
But I agree with what they say, but I'm also checking my weighbridge, because that's what's telling your asphalt pump what to do.
Okay,
That can cause some issues there too.
okay, good.
And hey, Jim,
Yeah,
you got to back up and like you guys remember, it's like you fix it on the fly or do a temporary shutdown.
Yeah.
This is where it's super important to get another test right away.
okay,
Because then you're going to know, well, was it a fluke or do I got to worry about stopping the operation?
okay. And Ray was mentioning he's actually going to watch his burn, and he's going to watch that rate of change
Right.
in his burn, which is which is a good idea. And if he's seeing it, again, you're looking for stuff that's different, not the norm. And so we see things that are not the norm, and you're confirmed by maybe a burn that's not the norm. Well, okay, that's starting to answer some questions. And obviously, if you've got a crew waiting and you've got mix on hold, and there's a lot of money waiting on this, but we want to make sure we're doing the right thing. So, but any of those little tips and tricks are very valuable in the process. And obviously, if our lab molds are running too high, and if it truly is too high, and it's
That's a
not,
pay factor.
it's a pay factor, and it's also a performance problem.
Yeah.
I mean, if there's not enough air in that sample,
Yep.
we could end up with flushing on the road. We could end up with rutting on the road. So there's lots of issues here from a performance standpoint as well, and it's going to cost you money. And the further you're away, we're getting out of our bonus opportunities,
Yeah.
as we like to talk about, and we need to take advantage of those because they're out there. They're out there in Texas. They're out there in Florida. They're out there in many states across the country, and we need to take full advantage of those whenever we can. So
I got a quick question for
yeah, go
when
ahead.
Scott says that he checks the weighbridge. Have you found that though that wind can have an effect on your weighbridge, Scott? I mean, if it's a really windy
Yes.
day, do you see that having an effect on your weighbridge sometimes?
Yes, it does. I mean, we get a lot. If we get a south wind, our weighbridge is basically blocked by our baghouse. We do have wind guards on the side of it over the weighbridge itself, but I mean, a windy day will push the material one way. I mean, and it can affect things for sure.
What you really want to look at, I think, is it's the gradation against the AC. When you see your gradation, if they're good and your AC's off, you got an AC problem. It only comes from two places: weighbridges and meters, right? So if the grades are good and the AC's out, you're locking down on your weighbridge or your meter.
Good point.
Good points. Good points, guys. Good points. Hey, let's move on. Let's talk about our rice gravities, our GMMs. They're shifting to the low side. Now, these aren't drop, but you're starting to see a shift in your quality control charts, and everybody should be running QC charts. So I'm not saying how much, but I'm just starting to see a gradual shift to the low side, or the actual numbers are getting lower. What would you look at? Now, again, I'm gonna go back to TJ on this one, since I think I've made it around the clock. What's the first thing that you're going to look at?
First thing we look at is wrap, where we have a GMM problem because we run high wrap and we run a lot of different kinds of wrap. And so soft limestones, harder limestones, granite. We've made assumptions, and if that shifts on us, our experience has been we start worrying about that, and we'll grab another one as quick as we can.
Okay.
And see what's going on.
Good deal. Lance, what are you gonna do?
When gravity shift low, it starts telling you that it kind of goes along with the other items that we've talked about, that you have high AC. So you want to go back and check all the things that we talked about before.
And you're never gonna blame the lab, right?
Of course not.
What do you think, Ray? You're gonna have to unmute yourself there, buddy.
This is on, yeah. I mean, just to say what everybody else is saying, it's, I'm going to look at RAP if we're doing a recycle project. That's when I'll see. And we had this happen just a couple of weeks ago. I don't know where our specific gravities jumped 25,000 from where we were seeing the day before. And, we went out and started checking RAP. They got into a new section of the RAP pile, and it was something small, but, once we figured it out, we didn't have a problem going forward. So, but yeah, checking that, making sure, we don't have too much AC or, just anything that would cause it the mix went fine or whatever.
Gotcha. Scott?
Yeah, I mean, this is one of those things. So many things can have an effect on it. The wrap. I mean, it could be your material gradations have changed. I mean, segregated samples. You're plant segregating something. I mean, there's so much that can affect that rice gravity.
Mm-hmm.
It's probably one of the quickest things we get back from our guys. From day to day. Because he can run that test as fast as anything. And he can give you, and a big fluctuation in there, may show something else going on.
Okay, good deal. All right, guys, we are running to the top of the hour here. I want to maybe give everybody one more shot. If you've got anything else that you'd like to share associated with troubleshooting and relative to quality. I know I didn't ask you about this ahead of time, but thought we'd have a little lightning round, if you will. Has anybody got anything else to say? Go ahead and weigh in. Maybe I'll have to call on you. Go ahead, Lance. Anything?
It's all about accountability and everybody wanting to do the right things. You plant operators. One of the things that we find that I've found here recently is phones, attention to detail, and all this stuff. The phones seem to take attention away from running the plant, so we try to keep phones out unless you need to. Just caring and really wanting to do the right things. I know that's kind of an easy thing to say, but it means a lot.
Yep. How about you, Ray?
No, excuse me, I agree. I think the biggest thing is the communication between the QC lab and the plant, and as far as my 1Bs also call into the plant, and ask about temperature, let them know, hey, I'm seeing too much, I'm too hot, it's too hot coming out of the truck. But what we find out on the QC side is as long as everybody's willing to communicate and not point fingers at each other right off the bat, things go a lot smoother. We know we have an issue. We just don't know where the issue lies. And it can be in our test results. We've had test results that we've had to retest, and my guys will do that. If they see an anomaly or an outlier, they know, hey, we're going to run another rice before we even report this. We're going to run another mold before we report this. But, a lot of that has to do with the plant. What I tell my plant guys is we don't know there's not a problem if you don't let us know there's a problem. If we don't know what to look at and start making the changes we need to.
That's a really good point.
And if everybody will do that, it's amazing how much faster these issues and these problems will get resolved. Everybody goes about their day, and we continue putting out great mix.
Good deal. Scott?
I'm going to chime in with Lance there. You've got to have a plant operator who cares about what he's doing and is on top of his game. There's a lot that goes on. And if they're not paying attention to everything they need to, and it's a lot in a day. I've sat in a control room many, many hours. I mean, there's a lot to keep.
Oh, I think we might have lost Scott. He was buffering, and I think we just lost him. So TJ, go ahead.
I'm reiterating what these guys, I'm reinforcing what these guys are doing. Communication is huge. Listen, everybody generally, I find, wants to do a good job. And we all make mistakes, and machines break.
Yeah.
So just communicating, And then keeping an open mind and having a punch list when test results go haywire. You know, kind of like we were talking about here, where do you look? Where do you go?
Mm-hmm.
It is great, you know, to communicate. I think the companies that are really scoring well are the high communicating companies.
Good close.
Because,
Good close.
you know, we all want to do good work. We don't want our lives to be difficult. And when we tell people, hey, we have a problem here, proactively instead of reactively. Hey, I think I've got a bad sample. I took, I don't like the way this truck looks. You know, talking to us, we might go look at a batcher and figure out, oh, we just had a cylinder fail. So, you know, we're going to have inconsistent mix. It's a machine. It breaks.
Right.
So I think this is good. I really appreciate the chance to be invited here.
Yeah, you guys did
I
great
really
today.
do. Thank you.
Yeah, you guys did great. Well, appreciate it. Big thanks to our panel today. Thank you, everybody, for weighing in. Chuck, you got any final words of wisdom?
The only thing that, and you and I have talked about this before, is that it's imperative that the guys out in the field, your 1B out in the field, your 1A at the plant, and then your plant operator and the plant or the supervisor that's running the crew are all on the same text when we're texting
Right.
data back and forth and
Group
communicating
text.
back and
Yep.
forth, that everybody is aware of that information. Hoarding information is not good for anybody.
Nope.
And sometimes we find that the 1B out in the field might not be reporting all the data back to, your guy at the plant or the guy that's at the lab. And then there's issues.
Yep.
And I can't stress enough the way that you can get more bonus. And we've talked about this over and over again. Maximize your bonus in Texas is to communicate. That's the way that you maximize your bonus. If we're communicating every sublot. So you guys out in the field, how many times are y'all calling the lab or the plant operator? Should be 4 times a day, every sublot. Every sublot, you should be communicating what you're doing out in the field and saying, hey, we got good numbers, looks good, temperature's good, densities look good, we're doing well. And if not, we need to communicate that. And that's the big thing. So communication is it. Lance and TJ and Scott and Ray, you guys are all right. It's all about communication. I agree with you 100%.
Hey, thank you. Hey, you got me speechless. And I'm going to stop there. I mean, great stuff today. Thank you so much for our panel. Thank you for participating today, and thank you for everybody. And again, take this information, share it, get it out there. There's really good information in here that will save you guys and save you money and save you a lot of stress. Take it, use it, imply it. Let's be safe out there. Keep washing your hands. Let's get rid of the COVID thing so we can get back to business. And God bless everybody.